to answer question 1, we have the board here, and question 1 is, when exercising at high intensities and breaking down lots of glucose and glycogen, what product is more likely to be formed compared to low intensity activities? And here we have a little flow chart saying what happens when we exercise. So when we exercise, we need more fuel, more glucose. So we're going to go through glycolysis. And through glycolysis, we'll end up with 2 3-carbon pyruvates. And the 2 byproducts of pyruvates are ACOA, which is used in the Krebs cycle, and lactate. And then, so you can see here with high intensities, lactate is produced more than at lower intensities. And how does your body utilize this product to maintain blood glucose levels and muscle glycolysis? So how lactate can go through GNG and go back to the glycolysis process is, or kind of how our body can use this lactate over again, because our body is very good at reusing products that have been made or just already in the body. So we have the Cori cycle here. The Cori cycle starts in the muscle, where we have glucose stored in the muscle, or glucose in the muscle. Then it's going to G6P, deciding whether it wants to be stored as glycogen or broken down into pyruvate, which is then broken down into 2 byproducts, lactate and ACOA. Then this lactate will go through the MCT of the blood muscle membrane and will continue traveling through the blood and liver membrane. And as lactate is in the liver, it can be reworked into pyruvate, reworked into G6P, and eventually getting us glucose again. So, and then glucose will travel back to the muscle where it can be used for more high exercise or just any, because glucose is a big energy source for our muscles. So it's always important to have more glucose in our muscles in case we need rapid intensity. And question or part B, explain the differences between glycolysis and glyconeogenesis. Glycolysis converts 6C glucose into 3 carbon pyruvate, where glyconeogenesis converts 3 carbon pyruvate into 6 carbon glucose. Glycolysis is exergonic, which is releases energy. Glyconeogenesis is endergonic, which absorbs energy. And overall, glycolysis gives us a net of 2 ATP and uses no GTP. In GNG, they are inputting 2 ATP in and only get 2 ATP out, therefore leaving us with a net loss, or 4 ATP in, 2 ATP out, a net loss of 2 ATP, and uses 2 GTP. So generally, GNG takes more energy than it would for glycolysis, but GNG reworks this whole system basically backwards to get us more glucose for our body. So yeah.